Hey guys, coming to this question now, which is 10.2. It's saying the Banana Airways aeroplane has 6 seats in each row. So this Airways an aeroplane has 6 seats in a row. So first question, 10.2.1, how many possible arrangements are there for 6 people to sit in a row of 6 seats? So 6 seats. So if I can put it like that, that's starting by list 1, 2, 3, 4, 5, 6. So we have 6 seats. So it's gonna be 6, 5, 4, 3, 2, 1. We times this possible arrangement, which is just 6 factorial. What is 6 factorial? It's 720. So the arrangement are 720 in order for these people to sit in the 6th row. So 10.2.2 now, it's saying Oliswa and Anis and other 4 passengers sit in a certain row on the Banana Airways flight. In how many different ways can these 6 passengers be seated if Oliswa and Anis must sit next to each other? So now we have these 6 seats, 1, 2, 3, 4, 5, 6. And then now we have these special people, which is Uxoliswa and Anis. These two, they just want to sit next to each other. They just want to sit next to each other. So now, if they want to sit next to each other, both of them here, they're gonna arrange themselves. It's either the one come at the first or the other one come at the last, but there's something that is going to happen here between them. So let's calculate whatever arrangement that is going to happen here. There are 2, so it's going to be 2 times 1, which is just 2 factorial, which is give us the answer of 2. Mind you, also these 2 people, if they move, they're gonna move both of them. Is either they come inside here, or they come here, or they come here. Whatever they're gonna come, the arrangement, they're gonna just be coming both of them. So if we count them, we're gonna count them as a unit. So it's 1, 2, 3, 4, 5. So we have 5 of them, so we're just gonna have 5 factorial. And what is 5 factorial? Is 120. Now let's calculate the arrangement or the ways that can be seated. Now how do we do that? We just say 2 factorial of this one, and then we times it with the arrangement of all of them, including these ones, which is 5 factorial. Just gonna get what? 2 factorial times 5 factorial, we get 240. So we have 240 ways of these 2 to be seated like this. Now let's go to 10.2.3. now they are saying Mary and other 5 passengers are to be seated in a certain row. If a seat are located at randomly, what is the probability that Mary will sit at the end of the row? Mary will sit what? At the end of the row. So now, if we can think how many seats we have, let's say we have 6, 1, 2, 3, 4, 5, 6. If I'm coming from this side, which is my left hand side, the end or the end of the row, if I come from this side, this is the end of the row. So if 1 2 3 4 5 6, if I come from this side, what is the end of this row? Is this side. This is the end. So we need to calculate both of them so that we add it, and then we can find what? The probability. So now let's say Umeri is gonna end here coming from this side. So we're gonna have one Mary, it's gonna be here. Then after we've used Umeri, we are left with 5 seats. So it goes 5 4 3 2 1, and then times it, which is just 5 factorial times 1, which is let's just leave it like that as 5 factorial. And then also coming now from this side, our end is here, so Umeri is just sit here. So from here we are left with 5 seats, so it's 5 4 3 2 1. Then we times it, it's just 5 factorial times this one, which is what? 5 factorial. Now remember, we are looking for what? For a probability. So first thing here, we did find the arrangement of the 6 seat. So we need this thing, we need to use it in order for us to find what? The probability of Umeri sit at the end of a row. We're looking for that probability. So how do you find the probability? We add these two, which is this our possible arrangement if Umeri sit what? At the end. So it's 5 factorial plus this 5 factorial all over the arrangement, the total arrangement, which is what? 6 factorial. And what is our answer? That's 5 factorial plus 5 factorial over 6 factorial, which gives us what? 1 over 3. I hope everyone understands it. Okay guys, coming to this question now, question 11. It's saying 5 boys and 4 girls goes to the movies. They are seated next to each other in the same row. Now coming to the question 11.1. Now it's saying one boy and girl are couple, okay, and they want to sit next to each other at any end of the row of friends. In how many different ways can the entire group be seated? Now we have these 5 boys, 1 2 3 4 5, and 1 2 3 4 girls. So 1 2 3 4 5 and then 4 girls. Okay, now this one boy and one girl, they want to be, is either they sit here at the end of this side, which is the right hand side, or they sit at this end, but they want to be at the any end. It's either they sit at this end or they sit at this end of the row. Now if they sit here, both of them, they're gonna arrange each other here. Also the same thing that happens here, it's gonna happen here, because arrangement is gonna happen here. It's either they sit here or they sit here. So let's first calculate what is happening between two of them. Obviously there are 2 of them, so it's 2 factorial. But what is happening here, it's gonna also happen here. So we're just gonna times this, because this thing that is happening is just happening 2 times. Just gonna times what is happening to them 2 times. And then after that, If we can now count, we have 1, 2, 3, 4, 5, then 6, and then 7. So now there's an arrangement that is going to happen here between these couples that are sitting here. There are 7 of them, so it's just gonna be 7 factorial. Remember, we take this as a unit, we also take this one as a unit. That's why we count them as 1, 1, and also here we count them as 1. So let's find different ways. So it's just going to be 2 factorial, I hope you do understand, times 7 factorial, which we get 2160. I hope you understand that one. And coming to the last question, which is 11.2, if all the friends are seated randomly, all the friends now are seated what? Randomly. Let's first find this first question, the random one. How many of them? There are 5 boys, so it's 5 plus 4. There are 9 of them. If they are seated randomly, let's just find the arrangement of them, which is 9. It's going to be 9 factorial, which is 3, 6, 2, 8, 8, 0. This is the arrangement that are just being seated randomly. This is the arrangement. Now calculate the probability that all the girls are seated next to each other. Want all the girls. So now how many girls do we have? We have 4 girls. So 1, 2, 3, 4. We have 4 girls, and then 1, 2, 3, 4, 5 of the boys. Now one of the girls, they're saying all the girls, so there are 4 of them. All of them, they just want to sit next to each other. All the girls, they want to sit next to each other. So just gonna put them in this box. The girls, remember, the girls inside of this box, they're gonna arrange themselves inside of this box. How they are going to arrange themselves? How many of them? There are 4 of them. So 4 factorial inside of this box, we get 24. And then now if we are going to count here, remember when we count this box, we count this box as what? As individual, and also counting the other boys and as individuals. So it's going to be 1 this box, 2, 3, 4, 5, and what? And 6. So now if we are finding the arrangement of all of them including the box, 6 factorial, what is 6 factorial? 720. 720. Remember, we are doing what? We are calculating the probability. So the probability of all the girls seated next to each other, seated next to each other. This is the probability that we are calculating. Then we already found the restriction that they gave us here, the arrangement based on this restriction. We just need to times the 2, just 4 factorial times 6 factorial all over the total arrangement if they are seated randomly, all of them, which is what? 9 factorial. If we can find the answer on that one, it's just 4 factorial times 6 factorial all over 9 factorial, which is 1 all over 21. This is the probability. ability.